root of 72?
I got. So I divided 2 by 72, which is 36. And then I divided it by 2 again, which is 18. And then I divided it by 2 again, which is 9. And then divided that by 3, which is 3. And then divided that by 3 again, which is 1.
Excellent. Excellent. We're going to write all of these values over here. 2 into 2 multiplied by 2 multiplied by 2 and 3 square or 3 into 3. Remember the concept that I gave you of a square root jail? Only there's a number 2 outside over here, right? There's a square root jail. Only 2 of them can join powers and one of them would come out. So this is 2. These 2 can join forces and one of them would come out. This number is going to stay stuck in there. What is essentially what is the answer at the end?
Six. No, 2 square root. Yeah, 6.
6 square root of 2. Perfect. Can you similarly try to solve this question? What's the answer for this?
That's just 7.
7.
Oh, yeah.
So
You do 7 square root
of
2. Square root 2. Yeah.
Let's put that to the test. But if you have your calculator with you, why don't you do 2 square root of 2 plus 5 square root of 2?
Yeah.
And put down your answer and see if it comes to be the same as 7 square root of 2.
Yeah, it is.
All right, perfect. What are we going to do over here?
We have to find them out individually first.
Now, this is the same question which asked us to write the answer in its simplest form. So you're supposed to add 2 sets together without the use of a calculator. I mean, obviously, if you're allowed a calculator, you can obviously do that in your exam, but I need to teach the concept first too. No? 32 can be changed into how many factors? And what are those factors?
Sorry?
If I were to divide 32 with a prime factor, what number can I divide it with?
You can divide it by
2, right? If it ends in an even number, I can divide it with 2. If this also ends in an even number, I can once again divide it by 2.
2.
Now?
Divided by 2. You can also divide it by 2.
Indeed. I'm going to keep on doing the process until I reach the number
1.
1. How many 2's are inside the square root jail? 2 into 2 into 2 into 2 into 2. How many of them can come out?
Only 4.
These
So
these two would team up. So
it would be 4 square root 2.
shabash. And if I were to solve this, I think we already solved square root of 128, didn't we? Oh no, we didn't. So what number can I start off with?
Could you also do 2?
Yes, indeed.
Divided by 2.
Whenever number ends in an even digit, we can divide it with 2. So I can divide it with 2 again, 2 again. And this process keeps on going until and unless we end up with the number 1. How many 2's in total?
7.
7. And how many of them are going to come out? One more.
3 pairs.
1, 2, and 3. So 2 into 2 into 2, and 1 still stays stuck in there. So what's the answer?
8 square root 2.
8 square root of 2. Do not forget the sign over here was a plus. So 4 square root of 2 plus 8 square root of 2 will give us?
12 square root 2.
Indeed. Indeed. We are almost at the end, if I'm not wrong. Yep. My target is to reach here. Since the concept of rationalizing the denominator, that's in your course. This is our final goal. We're going to be starting this tomorrow. However, I would want to finish these questions real quick. 3 more to go, right?
Yeah.
To express each of the following as the square root of a single number, I've solved the first question for you, I guess. Yes, I have. So, what's happening over here? We're supposed to change 2 square root of 5 into the square root of a single number. Do you understand what we're supposed to do over here?
Not really.
Okay. If I were to ask you to look at this solutions right in front of you, does this make sense now?
I don't really understand where 4 came from.
Okay, no problem. Let's go back and revisit the question. They're asking us, you've been given a certain number which kind of looks like this. For instance, 2 square root of, let's say, 4. Can we solve square root of 4 first and write this part as 2?
Yeah.
And can I just simply write this 2 which was outside as 2 again? Right?
Yeah.
If I were to solve these, 2 into 2 would give me 4. Now I would want you to plug in this into your calculator, 2 square root of 4, and see what you end up with.
Just 4. Yeah.
Exactly. The same that we came up with, but without the use of a calculator. This is what the question is asking you to do. Find the square root of a single number. Instead of the answer looking like this, they're asking you to it should either look like this. No, it should only look like this. For instance, square root of a single number. So there should not be any number out here.
Yeah.
Okay. The first question that we have is 2 square root of 5. How can we somehow combine this so that this square root sign, take a good look over here, the square root sign extends and involves that 2 too. Currently it looks like this. It should look like this. Square root of one single number. How would we do that?
Yeah.
Any idea? Think about it. Take a minute.
Would you do? Not. I didn't really understand that well.
I understand it's a bit of a tricky concept, and that's why I put this question right at the end. Let's jump to this. Do you notice a trend over here? Do you see something happening? This number gets doubled. This number stays the same.
Oh, yeah.
Okay.
Yeah.
Do you notice something over there? Instead of getting doubled, it's getting squared. So 9 squared is 81, and this 2 stays as it is.
Yeah.
If I were to ask you to solve this, what are you going to do? Without a calculator, obviously, we need to put it into this format. What do we do with
square root?
We square it.
Sorry?
What does this become?
9
9.
Times 7, which is 63.
And we write the square root of that.
Yeah.
Why do we do that is a question for another day. For now, I just want you to check whether this answer matches with this answer in your calculator.
Yeah. Cool. Yeah, it does.
Does it match?
Yeah.
All right. Here we go, right? The answer in its simplest form.
Yeah.
I think you must have already done square root of 72 if you've been taking notes. So I think we solved square root of 72 up there. Do we have it with you?
Yeah. 6.
6 square root of.
6 square root 2.
Well done. If I were to write 72 as 6 square root of 2, and if I keep 64 in the denominator as it is, can I simplify this a little further?
Yeah.
Can I simplify 6 with the 64?
Oh, yeah.
Is there a common number which divides both 6 and 64?
2.
2. There's 3 2's which can fit into, there's 2, 3 2's. And how many 2's fit into 64?
That 32.
32.
Just divide.
32. So when the question says write the answer in its simplest form, this is the simplest form. We cannot solve it any further. Does that make sense?
Yep.
Because 32, the 3 and 32 do not divide each other. 32 does not come in the multiplication table of 3.
Yeah.
Right? Can you try this on your own? Take a minute.
Yep. Wait,
Need help?
I think that let's just try and find the.
Had the question been 18 divided by 8, it would have been very simple, right? The only thing that's troubling us is the square root sign. So how do we deal with the square root sign? What do we always do? Start.
You find the lowest. Yep.
What do we do?
You find the lowest common multiple.
The lowest common multiple is supposed to be found when we're adding or subtracting two fractions. Now I know the process seems similar. We simply just call it the division method.
Oh, okay.
We're just trying to find the factors through this division method. So 18 divided by 2 gives us 9. Then this divided by what number can be divided by which? What do you call it? Prime number can be divided by.
3.
And now?
And then divided by 3. Yeah, again.
So we've ended with these 3 numbers. If I were to write it again, I can write it as 2 multiplied by 3 multiplied by 3.
Yeah.
How many numbers can go out of this square root sign?
3 times 3 will go out, so it would be 9 square root 9 squared root 2.
As far as 2 is concerned, you're correct. 2 is going to be inside, but we won't have 9 outside. What number are we going to have outside?
Wouldn't it?
Remember, I was telling you the joint forces, but how many of them go out?
3 times 3.
So only one of them would go out. Remember the joint forces, but only one of them breaks free out.
Yeah.
Right? So that's what the answer is going to be. 3 square root of 2 divided by 8.
Yeah.
One last question before we end it. Simplify the following. 2 plus square root of 3 plus 6 plus square root of 3. What should we do with the brackets?
We need to open them up.
Open them up. So 2 plus square root of 3 plus 6 plus square root of 3 square root of 3. How can I solve this further?
Would you 2 add 6 and then square root of 3 add 3 square root 3?
So if I add 1 square root of 3 plus 3 square root of 3, how many square roots of 3 do I have?
4 square root 3?
Indeed. Part 2.
Yeah.
Before I can open up the bracket, what should I do?
Do you times 5 like in between? Yeah. And then
Essentially asking me to multiply these, right?
yeah.
5 square root of 2. And if I multiply this with this, that's called the distributive law or the distributive property.
Yeah.
Which states if you have a number outside a bracket which looks like this, you're supposed to send that number to all of the elements or terms inside the bracket. So you end up with 2a plus 10. Are you familiar with this?
Yeah.
If I were to expand this bracket, what would the answer become?
5 square root 2 plus 5.
Indeed. And the second part?
Minus 3
Minus 3.
times 3 square root 2 add 3 square root 2.
Add 3 square root of 2. So we've got two terms which have square root signs and two terms which are just constants. What do we do with this? In fact, they're all constants. Two numbers which are integers and the other one happen to be in square root signs. What do we do now?
Do we add up 5? No, do 5 take away 3?
Okay, 5 take away 3, what do we get?
2, and then would the other one be 8 square? Add 8 square root 2.
Add 8 square root 2. So we've just done one question about addition, one about subtraction, and the last one is of multiplication, because this will help you in understanding this concept tomorrow that we're supposed to start. This is where we will end the concept of surds. Okay.
Okay.
So here we go. Expand and simplify. Are you familiar? First of all, are you familiar with such expansions in which you have got two brackets right next to each other, which look like this: 2a plus 3 into, let's say, 5a minus 1?
Yeah.
How are you supposed to expand these?
Well, you do 5 square root times 5 square root first.
5.
Oh my.
Let's try to apply this on this example above here.
Oh, this example.
Yeah.
You do minus 1 times 3. I think it's 3.
Let's start off with the first term. What are you going to do with the first term? You're going to multiply it with this, and then if you're going to leave it over here, are you going to multiply this with the second term as well? Now familiar?
I just can't remember the order. Like, because we use foil, I think. I don't know if you know.
I'm not familiar with foil. What's foil?
It's like first, outers, inners, and last.
Oh, okay. First, outer, inner, and last. How does that work? Can you give me an example?
Like
example for foil. I mean, if I were to write down a simple expression, let's say it's 2a plus 5 into a plus 3. How will we write this? Or multiply it?
Um,
This stands for first. What does O stand for?
so I think the first would be you do 5 multiplied by 3,
Okay.
and then 2a. I can't remember the order of it. 2a multiplied by 3, and again.
Okay. I personally feel this might be complicating things for you. What you're supposed to do is multiply the first with both terms of the second bracket, and then the second term of the first bracket with both terms of the second bracket. Is that easy to remember?
Yeah.
Let me repeat it. So this is supposed to go to this and this number, and then 5 is supposed to go to this number and this number.
Yeah.
All right. So if I multiply this term with this term, what do I get?
Wait, which term, sorry?
The ones that I've highlighted. This with
Oh, no, actually, it would be 2a squared.
2a square, and then if I were to multiply the same term with the second one now,
It'd be 5a. Oh, 6a, sorry. I had a number.
and now it's the term for the second term to get multiplied with the first term of the second bracket. What does this give us?
Just 5a.
And then repeat the process, but this time around the second term.
Just 15.
That's 15. What is going to happen is you're going to combine these two together. This will become 11a plus 15.
Yeah.
If I were to ask you to repeat the process for this is what it's going to look like. First with the first and second of the second term or second bracket, and then second with the first and second of the second bracket.
Yeah. So you do 5 multiplied minus square root 5.
So what the first term that you just multiplied 5 with 5, we're supposed to write that first. We're gonna write the answer first, and then move on to the second part. Second part now says you multiply the same number with the second term of the second bracket.
Yeah.
So what is that going to give you? 5 times negative square root of 5.
Minus 5 square root 5.
Indeed. Minus 5 square root of 5. Now we're going to repeat that process, but this time around, not with the first term, but the second term. This with this and this with this.
Yeah.
So what's the answer going to be?
You do 5, add 5, no.
No, if you
add 5 square root.
add 5 square root of 5. Well done.
Yeah.
And then we just left with one last step.
Would it just be minus 5?
Minus 5. Whenever you're multiplying a square root with the square root, that the square root sign disappears.
Yeah.
So this gets cut out with this. 25 minus 5 simply gives you 20.
Yeah.
Right? We're going to continue with part 2 from tomorrow, and then we're going to move on to rationalizing the denominator.